In the old photographs, the mountains do not look like mountains. They rise out of the haze as blunt cylinders, severed tables, blackened columns with crowns torn off. In the American West, in South Africa, in Brazil, in the empty interior of Australia, there are stone masses that look less like uplifted earth than like things cut short. A plateau here, a butte there, a ring of cliffs around a flat summit. From the air, some of them resemble the base of a trunk after the crown has been taken away. From the ground, they look larger than reason permits, entire horizons shaped like stumps. The accepted habit is to call them mesas, escarpments, volcanic necks, erosional remnants, but names are not explanations. And when the same shape appears again and again and again across continents, part in rock stripped bare as if something once stood there that does not stand there now, the first question is no longer what we are looking at. It is whether we have been taught to describe it too quickly. The official explanation is familiar. Ancient sediments were laid down in horizontal beds. Tectonic forces lifted them. Rivers cut them. Wind removed the softer layers. Time did the rest. Where hard caprock resisted erosion, flat-top mesas remained. Where magma intruded and hardened, volcanic plugs survived after the surrounding strata wore away. In this account, the landscape is not strange at all. It is the slow arithmetic of geology operating over millions of years. The timeline is immense. The mechanisms are standard. Erosion selects, gravity clears, freeze, thaw, runoff, collapse. The landscape becomes a museum of survival, where only the most resistant shapes remain. There is logic in that. There is evidence for it. And much of what we see can in fact be described that way, but only described. The feeling of completion is another matter, because there is a contradiction built into the scenery itself. Erosion is supposed to produce irregularity, yet certain landforms look unnervingly simplified. Vast vertical faces, clean perimeter walls, truncated summits, columns standing apart like isolated stems. In map view, some formations appear strangely circular or radially organized. In satellite images, others sit within surrounding terrain that looks shaved down rather than naturally graded. And then there is the scale problem. We are asked to imagine forests made of what we know now, trunks measured in feet, lifespans measured in centuries. But the landscape contains forms that force an older and less comfortable possibility. What if some of these severed mountains are not merely mountains? What if at least part of the world's tablelands, towers and stone pillars preserve the buried geometry of something biological on a scale no accepted model is willing to entertain? That is the hidden theory, not as a rant, not as a bedtime myth about giants. As an investigative possibility. There may have been, in some remote interval of Earth's history, biological structures of extraordinary scale, tree-like organisms so large that later observers, finding only their mineralized bases and shattered remains, classified them as geology because no other category could absorb them. Not every mesa, not every butte, not every column, but enough cases, perhaps, to matter. Enough to force a second reading of the record. The theory sounds extreme because the comparison is extreme. Yet what matters is not whether the claim flatters imagination. What matters is whether the physical pattern it points to has been seriously tested. The official explanation is established. The question is whether it is complete. What changed was the explanation. Start with form. In ordinary forests, a stump is a base wider than the trunk above it, anchored, flared, and distinct from the terrain around it. It is often ringed, cracked, vertically fibrous when split, and resistant where density is greatest. Now enlarge that logic beyond comfort. Across the Colorado Plateau, across Monument Valley, across parts of Siberia, Namibia, and Queensland, there are isolated stone masses with steep sides and flattened tops, standing above surrounding land like cut bases rather than uplifted ridges. Many do not taper like ordinary mountains. They rise abruptly, as if the adjacent material had been removed from around them. The slope pattern matters. True mountains tend to organize around peaks, ridgelines, and drainage networks. Many of these forms organize around perimeter walls. Their geometry reads as exposed cross-section. Their interiors often remain horizontally layered, which the official model treats as sedimentary bedding. But even here the visual logic is uncomfortable. The shape says severance before it says uplift. Then there are the vertical systems in stone that resemble grain. Basalt columns are one example, and geology explains them as cooling fractures. At the Giant's Causeway, at Devil's Postpile, in Iceland, in Armenia, in Ethiopia, that are rock contracts into polygonal shafts as lava cools. That explanation is solid, but the pattern becomes harder to dismiss when columnar structures appear alongside stump-like masses, radial fracture patterns, ring-like formations, and silicified textures that look less like ordinary stone than like material that has been reorganized from within. Petrified wood is not controversial. It exists. Organic tissue can be replaced molecule by minerals while preserving form. The record shows that cellular structure can survive stone conversion at remarkable fidelity. If replacement can preserve the anatomy of a log, why is the idea considered absurd at larger scales before examination even begins? Not proven, but pre-rejected. There is a difference. Consider the famous petrified forests. In Arizona, in Lesvos, in Patagonia, Arch and Yellowstone, entire trunks have mineralized. Some lie where they fell, some are broken into segments, some retain bark texture, growth rings, knotting, and cellular patterns under the microscope. The mainstream reading is straightforward. These are the remains of ancient forests, buried rapidly by ash, mud, or sediment, then mineralized over time. Fair enough, but what matters is the process this confirms. Organic material can be translated into stone. Form can survive transformation. And where the material is incomplete, broken, or massively altered, classification depends heavily on expectation. A polished specimen in a museum is labelled wood because it is small enough to recognize. A landmass 1,000 times beyond modern biological scale is labelled geology because no one expects wood to become landscape. And the threshold between the two may be less empirical than psychological. Old photographs deepen the discomfort. In the 19th century, survey images of the American West often captured vast dead stands, stripped plains, toppled trunks, root masses torn from ground that looked raw, flooded, or recently exposed. The official reading points to wildfire, logging, beetle kill, drought, natural die-off, settlement, rail demand. All true, in part, but many of the images carry a strange atmosphere of aftermath rather than ordinary decline. Fields of timber cut or fallen in ways that seem too uniform. Hillsides stripped to mud, huge root balls upturned from shallow soils as if anchoring systems had failed across regions at once. Early photographers did not know they were documenting evidence for anything beyond development and disaster. And that is precisely why the images matter. They are not arguments, they are residues. And once you place those residues beside the stone masses, the buttes, the pillar fields, the giant silicified logs too large to move without blasting, an older possibility starts to edge into view. The stone remembers. There is also the matter of scale distribution. The official explanation assumes separate categories. Mountain here, tree there, petrified log over there, volcanic neck somewhere else. But natural systems often repeat across scales. Branching appears in rivers, lungs, lightning, roots, cracks in drying clay. Columnar growth appears in crystal habit, basalt cooling, bamboo, fungal fruiting, ice structure. The pattern repeats. So when trunk-like forms appear at many sizes, out from recognizable wood to giant silicified logs to stone towers and flat-topped masses that mimic bases, a cross-scale question becomes unavoidable. Are we observing unrelated processes that merely resemble one another, or are we splitting one family of forms into separate disciplines because the implications of continuity would be too disruptive? Geology studies rock. Botany studies life. Paleontology studies former life. But what if the most disturbing cases sit directly between those jurisdictions, too mineral for one, too anatomical for the other? The mainstream explanation deserves to be stated fairly here, because much of it is not only plausible, but demonstrable. Mesas do form through erosion. Volcanic necks do remain after softer rock disappears. Columnar basalt does result from cooling fracture. And flat tops can preserve ancient surfaces capped by resistant strata. No honest investigation can ignore this. But the failure of the mainstream account is not that it explains nothing. It is that it sometimes explains too generally. It absorbs all anomalies into a broad vocabulary of erosion and deep time, without always testing whether the local geometry, texture, fracture pattern, and surrounding context justify that absorption. Why this flat top rather than a peak? Why these perimeter walls rather than a radial mountain form? Why this isolated cylinder in terrain that should have produced a ridge? Why this silicified structure with fiber-like internal organization? Erosion is powerful, but erosion can become a final answer long before it becomes a measured one. Maps make the problem harder to ignore. On topographic sheets and satellite imagery, certain formations display boundary behavior more like removal scars than depositional landscapes. Some stand within basins of stripped material. Others align in belts as though a once continuous system was fragmented and left in place only where density or composition resisted later destruction. In several regions, isolated buttes occur with spacing that feels less random than geologists usually admit, like a forest after clear-cutting, where only a few bases remain. This is not proof, it is pattern, but pattern is where investigation begins. The hidden theory does not require every landform to fit, it only requires enough of them to resist the comfort of ordinary classification. And when similar blunt forms recur on multiple continents, and often in ancient shield regions or in terrains marked by intense mineralization, the single case objection loses force. What remains is distribution. What remains is recurrence. The pattern does not disappear. Engineering language offers another clue. Humans name things by analogy, and those analogies often reveal buried intuition. We speak of trunks, branches, roots, crowns, grain, veins, nodes, beds, plugs, necks. Some of these words are metaphor. Some began as technical convenience. But when observers first encountered certain landscapes, their instinctive comparisons were frequently organic. Stone forests, tree rock, petrified groves, devil's towers, organ pipes, needles, stumps. Even where science later stabilized the terminology, the first recognition often came through form, not theory. And form matters because it is the one thing classification cannot fully erase. If a gigantic, mineralized, eroded biological base existed, what would it look like after burial, fracturing, uplift, exposure, and ages of weathering? Not like a living tree, certainly not. It would look partial, simplified, stripped to a geometry of survival. It would, in many cases, look exactly like something we would call a mesa. The legal and institutional record reveals something quieter. Categories govern what can be seen. Land surveys record timber, mineral, grazing, water, and later hydrocarbon value. Geological surveys divide formations by lithology, age, and process. Museums separate paleobotany from geomorphology. University departments train specialists inside inherited boundaries. None of this requires fraud, it requires structure. And if an anomalous landform carries economic value as ore-bearing rock, or if it sits inside a framework already mapped as sedimentary and volcanic terrain, there is little institutional incentive to ask whether the object also preserves a biological history on a scale that would overturn textbooks. Classification has momentum, bureaucracy has inertia, funding follows accepted questions, and so the strangest possibility is not actively hidden. It is filtered out before it fully arrives, not by a dramatic conspiracy, but by forms, standards, categories, and the cost of being wrong in public. Historical timing adds another layer. The 19th and early 20th centuries were obsessed with cataloguing the world, yet they were also the period when industrial extraction accelerated fastest. Railroads consumed timber. Had mines chewed through strata, dams flooded valleys, dynamite opened mountain faces, fossils were collected, traded, mislabeled, lost. Indigenous accounts were dismissed unless they aligned with settler science. Vast landscapes were renamed and recoded in the language of property. If there were transitional forms that blurred the line between wood, stone, and terrain, this was the worst possible time for them to receive careful, neutral interpretation. A petrified trunk became a curiosity. A stump-like plateau became scenery. A field of giant silicified fragments became road fill or quarry debris. The record is still there, but rarely in one place. A survey note here, an old photograph there, a museum drawer, a mining report, a place name that should not exist if the landform never resembled a tree. Then widen the scale further. I would consider the recurring combination of features: petrified woodfields, stone columns, flat-topped erosional remnants, circular and radial geologies, buried forests under coal measures, silicified root-like patterns in exposed strata, immense deadfall photographs from the settlement era, barren mud basins adjacent to steep isolated masses, and folklore from multiple continents describing the world as once covered by a forest greater than the one that survives. Official disciplines address these separately, but separate treatment can hide continuity. Coal itself is the residue of ancient biomass under pressure. Whole industrial civilizations run on compressed forest history. That is not fringe, it is geology. So the idea that the Earth once supported plant or plant-like systems far larger, denser, or stranger than those of the modern era is not a violation of principle. It is only a violation of scale, and scale is exactly where the discomfort begins. Geology will answer that atmospheric chemistry, gravity, nutrient transport, structural load, and vascular limits constrain plant size. Again, fairly stated. Trees cannot simply grow forever. Water columns cavitate, tissue buckles, energy budgets fail. But these arguments derive from modern plants under modern conditions. The deep past was not the present. Oxygen levels shifted, carbon concentrations changed, climate stabilized and destabilized in unfamiliar cycles. Entire biological designs appeared and vanished without analogue. The Carboniferous produced forests of forms that no longer exist. Giant fungi may once have stood where later observers expected trunks. Lycopsids, tie horsetails and club moss relatives has reached scales alien to the modern eye. When the official story already includes worlds of unfamiliar morphology, why does the possibility of even stranger giant arboreal systems become untouchable? The answer may be caution. It may also be habit. Look closely at the phrase natural wonder. It often marks a boundary in thought. A place is designated wondrous when it visibly exceeds ordinary expectation but remains institutionally settled. Devil's Tower is wondrous. Table Mountain is wondrous. Monument Valley is wondrous. The tepuis of Venezuela are wondrous. So are giant sequoias, petrified forests, basalt pipe formations, and coal seams miles across. Wonder allows contradiction to be admired without being integrated. The visitor is invited to stand beneath the object, feel scale, take the photograph, and leave classification undisturbed. But classification is exactly where the pressure lies. When a landscape repeatedly presents forms that look cut, sheared, mineralized, and biologically suggestive, wonder is not enough. The question is not whether every strange hill is a stump. The question is whether any are. Once that question is permitted, the landscape changes. And perhaps that is why the theory persists. Not because it is easy to prove, but because ordinary explanations leave behind a residue of dissatisfaction. People sense when a label has arrived faster than an understanding. They sense when a photograph contains more than the caption allows. They sense when a mountain looks like something else and are told that resemblance means nothing. Sometimes resemblance does mean nothing. Sometimes it is coincidence. But sometimes resemblance is the first surviving clue after context has been erased. In forensic work, in archaeology, in paleontology, investigators begin with partial forms, break patterns, odd residues. They do not begin by insisting the anomaly must conform to expectation. They ask what process could produce what remains. Here, what remains is immense, repetitive, and physical. Flat summits, vertical walls, mineralized wood, giant deadfall, coal continents, silica replacing tissue, a world that seems, in fragments, post-forest. There is one more unsettling possibility. If the theory is partly true, the loss was not merely botanical, it was civilizational in consequence. A planet once covered by giant biomass would imply different soils, different hydrology, different atmospheric dynamics, different energy reserves, different habitats, and by different myths grounded in observation rather than fantasy. It would mean that many of the raw materials on which later industry depended were not random deposits, but the compressed remains of a world more structurally alive than ours. It would mean the barren landscapes we call ancient may not be primordial at all. They may be aftermath. Stripped systems, decrowned terrain, trunk bases left where crowns, roots, and surrounding tissues were destroyed, buried, cooked, mineralized, or carried away. Not a fantasy world, a damaged one, the stone remembers. What changed was the explanation, and yet caution remains necessary. A resemblance is not a conclusion. A pattern is not a proof. To claim that every mesa is a stump is as careless as claiming none could ever be. The serious position lies between certainty and dismissal. I'd sample the textures, scan the interiors, compare fracture geometries, map the chemical gradients, test for structural organization inconsistent with ordinary igneous or sedimentary formation. Re-examine old specimens written off as curiosities, revisit early photographs without the comfort of inherited captions, build the question in public and let it fail if it must, but let it be tested on its own terms, because if even a small fraction of these forms turn out to preserve biological architecture at scales science has not yet admitted, then the history of Earth is not merely older than we think, it is stranger in form. So we return to the image. A horizon of severed stone rising from a stripped plain, a tabletop mountain standing where a trunk should not be, a field of petrified logs under a desert sun. It's an old survey photograph of a dead landscape that looks less like nature in balance than like a scene after removal. Separately, each object can be explained. Together they begin to speak. There is the official explanation. There is the visible contradiction. There is the pattern that repeats across maps, archives, engineering language, mineral processes, and forgotten photographs. And there is the deeper unease that follows from all of it. Perhaps the planet did not simply erode into these forms. Perhaps it inherited them from a living architecture so old and so large that later science, finding only the bases, called them stone and moved on. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.